know about linear regression? Let's take it piece by piece. So linear regression. What do we know? Anybody? Anything?
We know that could be two-tailed.
Oh yeah. Okay. So that's always two-tailed.
Also, the df is going to be n-2.
Right. So then under step 1, we know that it's going to be. I don't even know if we need to write h now. I might just write rho equals. I should write RHO, huh? Rho equals 0, and rho is not equal to 0. Does that seem reasonable? Like, can people sort out which one's H1 and H naught?
Yeah.
And then would you say degrees of freedom is?
n-2.
Right. And then you said degrees of freedom is n-2. Guess I should make that legible. Why not? Degrees of freedom is equal to n-2. And then the critical value is going to be from, you're going to look it up in the,
Pearson curve.
yeah, PPMC. That's what the cool kids are calling it these days, PPMC. And then also, what does it look like? It's not a hill. What's it look like?
Straight, like linear.
Mm-hmm. That's -1. That's 1. 0's in the middle. So our H naught, interestingly enough, is always kind of always that we're right around 0. It always seems to be that way. I was noticing that earlier. And then we have our shaded areas here and here. We have a critical value. We have a negative critical value there. Okay. What else do we know? Someone else.
It has data that's paired together.
Yeah, data is paired together. So this is kind of, I think, like in terms of how to ID it. Data is paired together. Data in pairs. Or it's paired together. Paired together probably makes more sense, huh?
Sure.
That probably is clearer. Or paired up. Paired together. Drew?
Is the claim H naught for linear regression?
Oh yeah. So it's a good comment.
Or is it
The claim, so chapter 10, the claim is H1.
H1? Okay.
So I'm going to put claim. Good catch there. We should take note of that. The claim is H1. Plus, thank you. Anything else we know? What calculator functions do we use? Alondra, or Michaela, one of you two? What calculator functions do I use for linear regression? Stat test. Oh, sorry. You said Lin Reg. T-test, yeah. And you have your data. You have your data in L1 and L2. You kind of make sure that make sure you put your X's and Y's in L1 and L2. Is there anything particularly special about? Well, maybe step 4. So there's something sort of special about it. So step 4. I'm missing a color. Orange. What's a good color? Someone give me a color. Choose a color.
Green.
Green? I have green. The bright green?
Yes. That's a good color.
People really want the bright green? Okay, you good with the bright green? All right, 4.
Yeah.
Remember that rejecting H naught means that what?
It's in the shade one.
It's in the shaded area. What does that mean?
It's a line.
It's a line. It's a line. Because if you're in the shaded area, that means that you're sort of near these sections here, right? You're close to 1. I should undo that. Here, you're close to 1. Right? So if you're close to 1 or negative 1, then you're aligned. Because 1's a perfect line. Okay, good. And then how about step, okay, so I should change the other green to something else. Pink?
Sure.
All right, so step 5. So either you do or do not have an evidence to, and since H1 is going to be my claim, support claim of correlation
Steps for each
between blank and blank, right? Whatever your X and Y are.
So, when you get your data that's paired together, usually, for the most part, it's like comparing whether one affected the other.
Whether they're correlated or not. So as one goes up, does the other one go up? As one goes down, does the one go down? Or as one goes up, does the one go down? So do they have a
Relationship.
relationship?
Okay.
Yeah. Yeah.
When it says that when you reject H1, it's a line, is that when you use y equals
Yes. Okay, so I want to talk. That's a great thing. We should talk about that too. So first, but real quickly though, how else can we tell? Well, I'll put that in there. That's perfect. So we also should talk about that, right? So that's about what do we call that? Is it estimating? What are we predicting? Predicting, right? Predicting. So you said if we reject H naught, it is a line. So then what would be used to predict? Y equals A plus BX. And again, we get all those values from our Lin-Rich t-test. On the other hand, if we do not reject H naught, reject H naught, then what? What was that? Yes. Then for Y we use Y bar. Then it is not a line. Not reject H naught, it's not a line. So then we use a sample mean to predict Y, and we use the if we want to predict X, we use the sample mean of X. Yeah, I love that. Great. Perfect. I'm feeling very confident about how things are going. Okay. Next, how else can we identify these? What's another way we can identify? So the data is paired together. What does it look like?
Well, in like the actual problem,
Yeah, sure.
we should say to test whether there's a relationship between
Okay,
X and Y.
should ask for relationship or correlation. Or it might literally even say something about linear. Might have any one of those sorts of comments. Okay. Good. What else? So there'll be two lists. So there'll be what do you call it? Labels. labels only on top or side, not both. And there's two lists. Okay, seems good. Right, so it goes like X, Y, data, 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 data. Right, like that. Or it could be, or it might be like this. Right. X, Y, data, 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 data. Oops, those didn't match up very well, did they?
We lost a screen.
Uh-oh, screen down. Move over here for a minute. Just a little bit of a, okay. So yeah, X, Y, and then They'll look like either one of those. Okay. Any other comments that people had to say or input they have about that one? That's for proportions, yeah. Okay. So now we're going to move on to chi-squared. Chi-squared lists first. You don't care? Sure, we'll go in order of the book. Sure. All right. So what are some things that we know? Okay, good. So on step 2, the degrees of freedom is going to be number of categories minus 1.
Oh, inverse.
Number of categories minus 1. And then what else did you say? What? Can I start with this? There's one row. Yeah. So there's kind of one row list. Let's say row. One row of observed. And it's interesting because it'll be like this. Label, 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 label. And all the top of data. It goes with it. These visitors. Right, so the and then the expecteds, you need to fill those in. That we expect you to compute.
Wait, shouldn't it be categories minus 1 and
That's for a matrix.
Okay.
This is just your observed is just that.
Okay.
Really. Right, and then you find the expecteds. Okay. Where do you find your chi-square from? Where do you find your critical value from? What about my step 1? Ryan, what's my step 1?
O sub I equals E sub I, and O sub I doesn't equal E sub I.
Mm-hmm. Which is going to be my claim.
H naught.
Yeah, that's my claim. Yeah, and then O sub I not equal to E sub I. Okay, good. What else do we have? Oh, step 3. Oh, all right. So there's a couple things. All right. So what's step 3? How do I find my step 3? Angelo, Daphne? Drew?
Yeah, so you do the observed value
Uh-huh.
minus the expected value and then squared divided by the expected value.
Do it for the first category. Do it for the second category. This is my test stat. For every category, right? So the first category, O1 minus E1 divided by squared divided by E1. Second category, O2 minus E2 squared divided by E2 is for the second category, and so forth. And you do have to write those out. I need you to write out those amounts of numbers in them. You know where they come from? Okay. And then 4 and 5 are really the same as previous. You know, they oh, well, 4 might be. Okay, so then 4 is the same, kind of same as always. Ooh, I should talk about the picture. So the picture goes like that. 0, and then put in your shade over here. You notice how like 0 is sort of at the beginning and it goes out that way? So it's interesting because H naught always says that you're kind of where 0 is in all of these, right? Because you think about it in a regular normal curve, your H naught says that you're smack dab in the middle, where your z-score is 0. For the Lin-Reg t-test we did before, it's a line. Again, negative 1's here, positive 1's there, 0's in the middle, and again, it's saying that you're in the middle, that row is 0. And same thing here. It's saying that that the observes equal to the expected. When the observes equal to the expected, if the observed and the expected were exactly the same, then what would happen when I took the observed and subtract the expected? What do I get? 0. Does that make sense? If the observed and the expected are equal, then when I subtract them, I should get 0. And then when you square 0, you get 0. You divide by something, you still have 0. So if the observed equal the expected exactly, then this will be, then my test stat will end up being right here exactly at 0. So again, H naught kind of always says that you're right there at 0. And then you kind of see how far you are away. If you're far away, then you're unusual. When you're unusual, you reject H naught. If anyone recalls you back when I was like, oh, if you flip a red card, you get a chocolate. And people got 5 or 6 black cards in a row. Is that unusual? Yeah, it's unusual. Someone's like, Ms. Young, that's total BS. That deck is not a regular deck, right? It's unusual. You get something unusual, you reject the null hypothesis and say that your deck is that your stuff is not the same as everybody else's. You're different somehow. Good. And remember, very often that's the goal. The goal is you're different. You get to write a paper, get published, yay, and prove that you get to prove something new in life. You prove that your drug works or your additive works or whatever it is. All right. So step 4. That's kind of the same, right? You reject H naught if unusual. that's, this is the unusual area over here. Good. And then step 5, that's the one where it says the claim is always going to be H naught, so it's going to be reject claim. So either you do or do not have enough evidence to reject claim that proportions are as expected. Okay, so speaking of expected, how do we find our expected values? I find my expected values. I have my observeds, and you find my expected values. I'm going to calculate those. How do I do that? Anybody remember?
Well, sometimes they're written as like percentages.
Okay, there we go. So sometimes, hold on, let me write that down. So sometimes they're written as percentages. So the percentage in each category is given. All right. So then what do we do if that's the case?
If that's the case, we can change it to like the actual comparable number to the observed. So you multiply it by the amount, like the number, if you add all the observed together, it will give you a number, so total people, right? So like if per observed, if the label under the first group was like 26, or 25, 25, 25, 25, that'd be 100, right? So you multiply the percentage by 100, which is total.
So P times N. N times the number of people you have total people you have, multiplied by the percentage you expect in that group. Right, so if it's like, if I said, I expect 60% of you to get A's. I expect 25%, I'll make this reasonable. Say 50% to get A's, 25 to get B's, 15% to get C's, and 10% to get to not pass. Then if there are, say there's 27 people in the class, then it would be 0.5 times 27. Well, I guess I should write the other way around, NP. 27 times 0.5.